Alright, now we got chapter 4, section 4, Isosceles Triangle Theorems. Remember, an isosceles triangle is a triangle with at least two congruent sides. That's how it's defined in this book. Some books say only two congruent sides. Here we're saying at least two. Okay, so first theorem, the Isosceles Triangle Theorem. So we have an isosceles triangle. We're calling it ABC. And since it's isosceles, we know that that is congruent to that. And we want to show that the base angles are congruent. This angle is opposite to this side, because this side has these angles in it, and that's opposite to it. C is opposite to AB. So these two angles are with this side, and the one left over is opposite to it. So we want to try to show B congruent to C. We want to see if we can make that conclusion based on the fact that it's a triangle with two equal sides. So we can say first of all, triangle ABC is isosceles. That's all we know so far. That's a given. And then we can conclude from that that AB is congruent to AC. Definition of isosceles. Okay. Now, what we're going to do is draw a segment down the middle, because we're allowed to draw stuff, right? That's not given in the world. You got to learn that you can do stuff to the world. As long as you're logical about what you do in a diagram, you can do anything. As long as you back it up with logic and the postulates of geometry and your prior theorems. So we know that we can draw a segment here, okay? And we've seen that an angle can be bisected. So we're going to draw specifically a bisector. So put a M down here. So we got AM bisects angle BAC. Because any angle can be bisected. Okay. Now, notice it's looking like, hey, we got some triangles, so we're going to show triangles are congruent, and then show B and C are congruent. So we got this big triangle, and we broke it up into parts, left triangle and right triangle. Because remember, what we have so far to show angles are congruent are parallel lines and triangles. Doesn't look like we got any parallel lines here to me, so we're probably using triangles. But we got to create them because we only had one to start with. I made BAM and MAC. We got two triangles now. Okay, but hey, look, we got this angle and this angle, and I repeated drawing on that line. You got to pay attention to what you're doing. That's included in both triangles, both angles. So let's say first we got, call it 1 and 2. Angle 1 congruent to angle 2. Definition angle bisector. But we see AM congruent to itself identity. And then we know we got side, angle, side, side, angle, side. Hope you're learning to recognize that more. It's the angle made up of the two sides. Not just any of them, but angle made up of the two sides. So we know triangle BAM is congruent to triangle CAM. Side angle side theorem. And therefore, since we know the triangles are congruent, we know the parts are congruent. So this triangle is congruent to this triangle, and therefore this angle is congruent to that angle. So 7, angle B, congruent to angle C, with our CBCDC. Try to learn to say that really fast. Since the triangles are congruent, their parts are congruent. Okay, so there's theorem 1. Now, let's go over the next one, the converse of it. Okay, so what we've done is when the sides are congruent, the base angles are congruent. This time, we're going the other way. We're going to start with base angles being congruent and show that the sides are congruent as a result. Okay? So we're going different ways, and we've talked about that before, how going from A to B is not the same as going from B to A. So we've got A, B, C, D. A is on top. Okay, we're starting with this. We know angle B congruent to angle C given. Okay, and of course this is on page 136, theorem 4.2. Now we got to show that AB is congruent to AC. I'm going to see if that's true or not. So, what do you think we'll do? Try to use triangles. Done a parallel lines. So we'll try to use triangles to show that those sides are the same. But we only have one there. So again, we have to draw lines to make this happen. So we're probably going to be doing something down there. Okay, so if we do a midpoint, if we do same thing, so we got this angle, this name is this. If we make it a bisector, then we got make AD bisector of angle A. We'll call it BAC, I guess. Okay, and we got we know any angle can be bisected. We draw a segment. Then as a result, we know that 1 congruent to 2. Definition of angle bisector, and then we got to show the triangles are congruent. So we've got an angle, and remember we have, let's see, side, angle, side, angle, and side, side, side. We got those to work with. We're trying to prove AB and AC are the same, so we can't be starting with all the sides. And we don't know any of the sides yet, really, so we're not sure about that. So it's probably going to be this. But notice we've got two angles, and we can't do angle side angle because we're trying to show that's the same. The same as AC. And if we started with AB congruent to AC, and then proved AB congruent to AC at the end by talking a bunch, that's circular reasoning. You're assuming what you want to prove. That's illogical and invalid. You cannot sneak in what you want to prove. You know, because then you're just going back in a circle to your original starting place. So it's the fallacy of arguing in a circle. Circular reasoning. So we see that they do have this line in common. AD is the same in each one. If we could just get two angles on it, because now we have angle, angle, side. And that's a theorem, but we haven't proven it yet. Angle, angle, side. But what we can do is say that because of one of our theorems, that if two angles of a triangle are congruent, the third must be congruent. And that was in our parallel line stuff. Let me look that up. We're talking about angles of a triangle. Yes, on page 94, corollary 1. Page 94, corollary 1 to theorem 311. So by corollary 1 to page 3, to theorem 311, we know that 3 and 4 will be congruent. But then we can do angle, side, angle. Angle, side, angle. Okay? And this time, instead of drawing 3 arcs, I'll just do 1 arc with a circle in it, so you can differentiate and know that this isn't the same as that. That's an option we have sometimes. So notice we have angle, side, angle, angle, side, angle. So the triangles are congruent by that theorem. We got to put down that AD is congruent to itself. Identity, and then BAD is congruent to BD, CAD, whoops, and that's angle side angle theorem. And therefore, since the triangles are congruent, the parts are congruent. So AB is congruent to AC. Done. With our wonderful CPCTC again. All right, so that's the corollary, or the converse theorem, sorry. So to sum up, the first theorem said if sides are congruent in one triangle, then angles are congruent in that triangle. It doesn't mean if any sides anywhere are congruent, then any angles you want to make up are congruent. You got to remember the context. So this is important in helping you think about when something arises in what context you can use it. In one triangle, if two sides are the same, then two angles in that same triangle are the same. Or the converse we just did was if in one triangle two angles are the same, then the sides opposite those angles are the same. This is opposite that, and this is opposite that. Okay, let's try one exercise on this. We'll do page 137, number 3.